Okay, hi everybody. So what I'm going to do is show you guys how to do gas stoichiometry. It uses a lot of the same concepts from regular stoichiometry, but when we have a gas at standard temperature and pressure, aka STP, we get to use a new conversion factor. So there are a couple of guided practice problems. First one, liquid water is synthesized from hydrogen gas and oxygen gas. If 56 grams of water are produced, what volume of hydrogen was used in the reaction if the reaction occurred at 200 degrees Celsius and 1.55 atmospheres? All right, so first off, I said that you get to use a new conversion factor if the gas is at STP, which is 0 degrees Celsius and 1 atmosphere. If we look, those are not the conditions that we have for this particular problem, which means we don't get to use that conversion factor 22.4 liters, okay? What we do have is a mass of water, and we need to calculate the volume of hydrogen that was used. With any kind of stoichiometry, doesn't matter what kind, what you have to do first is you have to have a balanced equation that links those two substances. So it says liquid water is synthesized from hydrogen and oxygen, which means that water is our product. And hydrogen, diatomic, and oxygen, diatomic, are the reactants. So then if we look at the equation, it's not balanced. We have 2 oxygens on the reactant side. We need 2 on the product side. So I double it, and then I have to double hydrogen. So now this is a balanced equation. If we look at what we have, we're starting with this mass of water. And with any stoichiometry, you write down your starting amount you're given, and then you drop your unit. If I have grams, then that mass is going to come off of the periodic table. So the molar mass of water is 18.015. And always on the other side of that line, we put 1 mole of the substance we're dealing with. Draw the line, drop the unit. Now we're starting with water, but we're trying to get to hydrogen. So 2 moles of water are produced from 2 moles of hydrogen. And this is actually where we're going to stop. Okay, if our gas was at STP, standard temperature and pressure, then I could continue my dimensional analysis and say 1 mole is equal to 22.4 liters. But we can't do that, so I have to stop here, okay, because it's not at STP. We'll go ahead and multiply across the top, and actually any number that's exactly the same, top and bottom, cancels out. So really I just need to multiply 56 times 1, that's 56, and divide it by 18.015. If you do this in the calculator, you end up with 3.11 moles of H2. Remember that moles is represented by the letter N in our gas law problems, okay? So I have N, we have a pressure here, we have a temperature. Question is, what's the volume? So the gas law that includes all of those things is the ideal gas law. So we need to plug all of this information into PV equals nRT, okay? Pressure, 1.55 atm. We need to find the volume. Moles, 3.11. R, remember that depends on the pressure unit. Since we're dealing with atmospheres, the R unit is going to be 0.0821. And then the temperature is 200 degrees Celsius, but we have to add 273 to convert that to Kelvin, so it becomes 473. Okay? So then you multiply the side that's all numbers, and you divide it by the side next to the letter. So it should be all this multiplied together, get that answer, and then divide it by 1.55. And so when you do this, I believe you end up with the volume of 77.9 liters. That would be your answer. So when your gas is not at STP, you are going to have to stop at the mole ratio, calculate moles, and then use the ideal gas law. Okay? If we look at the next problem, it says using the balanced equation for the synthesis of water, so that's this up here. We've already got the equation, so that step's done. Calculate the mass of water produced, so we've got to get grams of water. If 78 liters of oxygen gas and 40 liters of hydrogen gas at STP are used in the reaction. So here are the magic words right here, at STP, standard temperature and pressure. That means I will get to use the 22.4 liter conversion factor. But if you look at this, we actually have two starting amounts. So just like with regular stoichiometry, if you have two starting amounts, this is a limiting reagent problem, you have to work it out twice. And when you work it out twice, you'll end up with two answers. Whichever one is the smallest answer is the theoretical yield. That's the answer, okay? All right, so I'm gonna start with the first given amount, 78 liters of oxygen, O2. Draw my lines and drop my unit. Something about liters has to go here, and that's the new conversion factor. 22.4 liters is 1 mole of oxygen at STP. Then I can draw my line and drop my unit. We have oxygen, but we need to get to water. We're trying to calculate the mass of water. So if I compare those two things, 1 mole of O2 produces 2 moles of water. Draw my line, drop my unit. If we're trying to get to grams, then my last conversion factor is going to be the molar mass of water. So we multiply across the top, get an answer, and then divide by the bottom, 22.4. When you do that, I believe you end up with 125 liters. Okay? All we have to do is repeat that process, but we're going to start with 40 liters of hydrogen. So write down your given amount, draw your line, drop your unit. Again, if I have liters, it doesn't matter that it's a different substance. This 22.4 liter conversion factor applies to all gases. Draw the line, drop the unit. If I look at the equation, 2 moles of H2 produce 2 moles of water. So it's a 2 to 2 mole ratio. Draw my line and drop my unit. And since again, we're trying to get to grams, the molar mass goes here, and I can do my calculation. So again, we multiply across the top and get an answer, multiply across the bottom and get an answer. The top product divided by the bottom product equals the final answer. And I believe for this one, I think it's 32.2. Oh, and actually, the unit here would not be liters, it would be grams of H2O. And that would be the answer because it's the smaller of the two calculated values. Okay, so I hope this helps you with gas stoichiometry. Again, you have notes that can help you that we took in class, so use those notes to help you with your calculations.